Hello, everyone. The main focus of my presentation today is going to be on Alba Mons mapping, which I've talked about in recent years. But before I get into that, I just want to give a couple of updates on other projects that I've been involved in. In the upper left is the Xanthi Terra map that Dan Berman led, and I was a co-author on, and we're pleased that that's been accepted and into production. Center bottom is the Guinevere-Planitia quadrangle. That was one of the old Venus maps like Jane's, and I'm happy to report that that was submitted in August of 18, got the reviews back a year later, and that's been revised and resubmitted as of April. And I know it's on Jim's large pile of things on his table, but we're anxious to get that back and move that along. And then I'm also happy to say that we have on the right a newly funded project combined with some terrestrial analog work. We're going to be producing a new map of Gusev Crater, and that's an SSW project that's just started. Next, please. The main focus of my work in recent years has been mapping both the southern and northern parts of the Tharsis region. You see in the MOLA image in the middle, Central Tharsis is being mapped by Dave Williams, Pete McGinnis-Mark, Brent Gary, Jake Bleacher, and Kyle Moore in various combinations. And the quadrangles I've been working on lately are numbered 1, 2, and 3. Again, I'm going to focus on Alba, but I am actively working on all those quads. Don't have funding for Dedalia anymore. We're in the final year of the Alba funding. I am hopeful that I'd like to have 2 of those maps submitted by next year this time, and the third one by the end of 2021. The Dedalia map, I'm in the middle of writing the text for, and I'll update you on the Alba maps. They're progressing well, and I think we're on schedule to get those submitted shortly. The science goals for both of these areas really are to use the high resolution data sets, in particular CTX, but also combined with Themis and MOLA, to really delve into the details of lava flow fields on Mars. And you see on the right an image south of the summit of Alba Mons, where you have some really nice tabular lava flows which have surrounded a volcanic ridge with a curvilinear series of collapse depressions that I think define a lava tube. So we're able to untangle a lot of the stratigraphic details within the volcanic flanks. And then, of course, looking at the processes related to those, and also trying to pull out the temporal sequences. That's our other main focus. Next, please. So these are the 2 Alba quads. The western flank in the upper left, that quadrangle is complete. And the summit quad is nearly complete. We've mapped the fluvial features in blue. The lava flow margins are shown in purple. The caldera units have been mapped. What is not finished on the summit quad is the tectonic and other structural features, which are actually quite dense across the northern flank of the volcano. So the western flank map is done. The DOMU is done. I've done a combined COMU and DOMU for both of these maps, which we'll look at in a second. The unit scheme that we've come up with is fairly simple. The details on this map are in the structures and the cross-cutting relationships between different structures. Next, please. So again, having said that, this is a little different than other maps that I've done where the unit scheme has been much more complicated. In this case, we have in the lighter pink, the basic lava flow covered flanks of the volcano, and in the darker color are areas that were fed by lava tubes, and they appear to be a little bit older than the main flanks. We've pulled out a lot of detail in terms of cross-cutting relationships. I'm not going to go through the bullets on this slide, but We have a lot of local relationships, and we will build that into our map publication and document that in data tables and also with some symbology on the maps. Next and final slide, please. We spent a lot of time looking at the crater counts and trying to pick apart the flanks of Alba Mons. You see with the crater size frequency distribution at upper left, you get very nice fits and can extract ages. The punchline here is that all of the units that we see are early Amazonian for the flanks and summit area of Alba Mons, constrained within, excuse me there, I've got a dog barking, constrained within about a billion years, between 1.5 and 2.5. The chart at the bottom shows some different fits for both the tube-fed flows and the main flanks, the lava flows. Depending on how far you go down in terms of your crater size, you will get a different answer, but they're all within this early Amazonian time period. And so there appears to be a very large outpouring that formed the majority of the flanks of Alba at this time. And I'll stop there. Thank you.